This second video on statistics basics focuses on significance levels. A study of the effect of a corticosteroid on bleaching-induced tooth sensitivity found no significant difference in tooth sensitivity between the corticosteroid group and a placebo group, but found significant whitening for both groups. Anytime a research paper uses the word significant, it refers specifically to the results of a statistical test and relates directly to the significance level. Significant results should not be interpreted as reflecting clinical or practical significance. Researchers compare their sample results to the results they would expect when the null hypothesis is true, and they are generally looking to reject this hypothesis of no difference. When results are statistically significant, it means that the null hypothesis was rejected. So in the case of tooth whitening, the researchers rejected the null hypothesis of no color change after bleaching. But they did not reject the null hypothesis of no difference in tooth sensitivity between the two groups. Let's return to the study of plaque accumulation for two orthodontic systems. The null hypothesis is that there is no difference in mean plaque index between the two conditions. And the research hypothesis is that the mean plaque index is higher for those with the elastic module. The researchers begin by assuming that the null hypothesis is true, and then they create a model to represent this hypothesis. The x-axis shows all the possible values for the sample mean difference when there is no real difference in plaque accumulation between the two conditions. And the y-axis shows the frequency or proportion for these values. Mean differences favoring self-ligating brackets fall above 0, and mean differences favoring elastic modules fall below 0. The total area under this distribution represents 100%, or a proportion of 1. These are all the possible results and their likelihood when the null hypothesis is true. The area between any 2 points on the distribution represents the probability of obtaining this range of values when the null hypothesis is true. Although most of the potential sample mean differences are near 0, it is still possible to get values out in the tails of this distribution. Values relatively far away from the mean difference of 0 are possible because samples fluctuate, and therefore results can vary from what we might expect to see when there are no true differences between the conditions. The researchers believe that the elastic modules will result in greater plaque accumulation, so they're only looking for differences in the upper tail. This is called a directional or one-tailed hypothesis test. The researchers' task is to decide how far out on the upper tail they are willing to go before deciding that such results are so rare that they will take them as evidence against the null hypothesis and for the research hypothesis. They make this decision by setting the significance level. The significance level, alpha, is the maximum risk researchers are willing to take of rejecting a null hypothesis when it's true. Researchers are risk-averse, so they tend to set this very low. The most common value is 0.05. This corresponds to the upper 5% of this distribution. Because there is only a 5% chance of getting results beyond this point when the null hypothesis is true, the researchers are fairly confident that the difference is real. 5% is the conventional value used for the significance level, but the significance level may be set as high as 10% and generally not any lower than 1%. 0.05 represents the area in the upper tail of this distribution. Mean differences in this region can still occur when the null hypothesis is true, but occur so infrequently that the researchers are willing to say that such results reflect true differences. Therefore, any mean difference that falls in this area will be taken as support for the research hypothesis. That is, the results would be considered statistically significant. Setting the significance level gives researchers a decision rule to follow when they collect their data and run statistical tests. Any result that can occur by chance, that is, when there are no real differences, less than 5% of the time will lead to rejection of the null hypothesis. For this reason, this area is often referred to as the rejection region. To summarize, researchers begin their study by stating the null and research hypotheses. They then construct a model of the distribution that represents all the possible results when the null hypothesis is true. The distribution may take other shapes depending on the research question, but the process is the same for all hypothesis testing. The researchers set the significance level, which represents their maximum tolerance of saying there is an effect when there isn't one. This provides them with a decision rule to follow after they collect their data and analyze the results. The next video in this series focuses on the p-value and how researchers decide whether to reject the null hypothesis.